Hello. This video is a summary of our 460J final project, which explored using NLP techniques to predict the political leaning of tweets. Our project started off creating datasets of tweets, and from these datasets, we used BERT as a base model and experimented with other models on top of it. And then from these models, we tried to see whether Twitter, based on the locations of these tweets, matched the election results.
Yeah, so the first step in our problem solving statement was to mine our data. So there was no available data sets which met our needs. So our first iteration was to get tweets from specific user handles on Twitter. And we got those tweets from Kaggle datasets as well as IEEE dataset, and we mine those data sets for tweets from our hand selected users. But this was limited, and this only yielded 2,000 rows. So in the middle of our project, we found a better data set, which was from an archive. And we created this data set from this archive, and we combined another data set which had information on users and their party affiliation, and we were able to create a data set of 500,000 entries, and which were labeled based on party, um, which which was a lot, which enabled us to train on some more complex models.
So before we trained any models or made any predictions, we did some topic modeling using NLP and LDA. First, we used NLP only on election-specific tweets. And to do this, we pre-processed our tweets to remove irrelevant text. And then we used the bag of words technique to find the most commonly occurring bigrams throughout the dataset, which we extrapolated the most popular topics for certain parties through these bigrams. Similarly, we used LDA on general politically affiliated accounts to find the topics that were most prevalent throughout the political climate and not only party-specific election-related tweets. Here you can see on the left side, we have a topic model of the NLP results from our Democratic Party. And as you can see, they prioritize things such as COVID-19 and Joe Biden. And on the LDA, we see a word cloud of the most prominent topics spoken about throughout the political climate.
Yeah, so now I'm going to be talking about how we actually trained our models. We followed kind of the same procedure for all of them. Like was mentioned earlier, they were all based off the BERT architecture, which we used Hugging Face's implementation of it, specifically the BERT for sequence classification class, which was helpful for us because it had a logistic regression layer stacked on top of BERT already, which left out some work for us to do. We also used initial weights from Hugging Face called BERT based on case. It's a smaller version of the version of BERT used in the research paper, but still provided us with good results and shorter training and iteration time. After we got our model running, we had to fine tune on our downstream tabs, whether that be on the election tweets or broader political tweets. As we're going to talk about earlier, we tried varying test sizes because some of our data was too big, and we wanted to see how the test or the trained data size would affect our models. We also employed hyperparameter tuning with cross-validation. We used a library called RayTune to accomplish this and managed to integrate it into our existing training scripts. We also did try out other classifiers like MLP classification, as well as XGBoost stacked on top of BERT.
Yeah, so after training the models, we found some pretty interesting results. For our election tweets model, after tuning, we found that simple linear regression gave us an AUC of 0.83 and a 75% accuracy, which we thought was pretty decent. We also tried implementing MLP and XGBoost on top of our BERT model, but we found that this actually gave us lower AUC values. For our political tweets models, we broke it up into separate 5K, 10K, 50K, and 100K sets to analyze and track the improvement of AUC as our data set increased. And we found that there was a large increase in AUC from 5K to 10K, as well as a significant increase in AUC from 50K to 100K datasets, which allowed us to obtain an AUC of 0.95, which we thought was pretty impressive. And one approach that we tried was using the larger BERT model, but we found that this increased processing time significantly while only marginally increasing the AUC. So we found this to not be very beneficial.
So first, we got a data set of 300 tweets around the election time and labeled it using our model and went through it ourselves just to see how the results looked. And the results were pretty good. Like, for example, Make America Great Again and Real Sad, both in all caps, are labeled as a Republican, as they were more likely tweeted by someone who leaned Republican. And then also, the Republicans are supported by a lot of voters, and they like to show that off. So someone tweeting tons of votes for president in California was also Republican. For Democratic tweets, there were some tweets like, we agree that Trump is a fascist, because someone who thinks that is Democratic, and also someone who votes for Biden or Harris would also be classified as Democratic. Okay, so we used our model to make election predictions. So using a data set of election tweet IDs, we got 7 million tweet IDs occurring from October 12th to November 3rd, as this is the time early voting was occurring. We used a Twitter hydrator to hydrate 1 million randomly sampled tweets from this out of the 7 million and get the full text and location. We then used the model to label these tweets, and then we broke down the results by state. So even though every state had more Democratic tweets, our results were interesting, as out of the 20 states with the highest Republican percentage, Trump won each one except for Georgia and Maine. As you can see, Biden easily won Vermont, New Mexico, Oregon, Minnesota, Illinois, and then Trump won all of the states on the right except for Maine and Georgia. And both of those were also close.
So I guess in conclusion, what did we learn from this project? Primarily, first thing we learned was how to collect data from the Twitter API at scale, how to get around the Twitter rate limits to obtain the data that we needed for this project. We also learned a lot of NLP techniques, including LDA, to create comprehensive breakdowns of topics and create the topic modeling diagrams that you saw earlier. We also learned how to use BERT and how BERT worked, as well as how to fine tune it on downstream tasks like we did in this project. And then as part of that, we also learned a lot about how PyTorch worked and how tuning deep learning hyperparameters worked as well. So overall, it was a great learning experience. I think we showed some interesting results regarding the 2020 political climate.